Assalamualaikum and hi everyone. In this video, I will focus on the steps of solution to determine the bearing capacity of shallow foundation using the Terzaghi's equation. Terzaghi was first to present a comprehensive theory for the evaluations of ultimate bearing capacity. These are the Terzaghi's bearing capacity equation that will be selected based on the type of foundation. So we have the strip foundation, we have the equations for the square foundation, and we have the equation for the circular foundation. And this is the Terzaghi's bearing capacity factor. As you can see here, the column of the table here, we have the angle of friction, okay, from 0 to 50. And you can see here that we have the bearing capacity factors, N subscript C, N subscript Q, and N subscript gamma. So we will use this table in order to complete the solutions of the example. Okay, now we will proceed with the example 1. Okay, based on this question, we need to use the Terzaghi's equations to determine all the parameters that we need here. So we need to determine the allowable bearing capacity, Q subscript all. We need to determine the net allowable bearing capacity. We need to determine the allowable load, capital letter Q subscript all, and the net allowable load. So for all this equation, we need to use the factor of safety FRs equal to 3.0. As you can see here, these are the problem given. The properties of the soil. As you can see here that we have the cohesion, we have the unit weight, and we have the angle of friction 25 degree. And the depth of the foundation is 1.5. And the size of the foundation given here is 2 meter times 2 meter. Means that we have the width of the foundation is 2 meter times with the length of the foundation is 2 meter. Okay, so the solution. So what is the first step of the solution? So we need to identify the type of shallow foundation since we have the types of shallow foundation equation. All right, so since we have the circular, we have the straight foundation, and also we have the square foundation. So in this case, so as you can see, based on the size given, which is B is equivalent to L, 2 meter times 2 meter. So obviously this is a square foundation. Then we need to identify the suitable Terzaghi's equations to be used to solve this problem. Knowing that it is a square foundation, so we will use this equation. Q ultimate is equivalent to 1.3 C cohesion times with the bearing capacity factor N subscript C plus with the Q times with N subscript Q plus 0.4 gamma times with the width and also times with the N subscript gamma. Then we need to identify the bearing capacity factors based on the angle of friction. So now we need to refer to this table of the Terzaghi's bearing capacity factor based on the angle of friction given 25 degree. So we need to identify, so this is the angle of friction for 25 degree. So now we can have all the bearing capacity factors for NC, NQ, and N gamma. Then we need to calculate the ultimate bearing capacity Q U based on the equation that we have select for the square foundation. All right, so now you will notice here we have the Q, the surcharge here. All right, so it's actually equivalent with the gamma unit weight of the soil times with the depth of foundation. So this is the overburden surcharge or the overburden pressure that received from the soil at the foundation location. Okay. Now we already have all the bearing capacity factors, so we can complete the calculation. So we just substitute the value. So 1.3 is here. And then we have the C cohesion. This is the C cohesion. So we have 20 kilonewton per meter square. And we have the NC here. This is the NC. Plus with the, for the Q here, so we have the gamma times with dF. So this is the unit weight, 16.5 kilonewton per meter cube, times with the dF is 1.5 meter. And don't forget to times with the bearing capacity factor for NQ. Now we have the last term, which is 0.4, 0.4 times with the unit weight, the gamma 16.5, times with the width or the B here is 2 meter, and times with the bearing capacity factor for N gamma. So complete the calculation. So you will have the Q ultimate is 1078.29 kilonewton per meter square. Okay, now back to the main question that we need to get the Q allowable. All right. So we can calculate the Q allowable using this equation. Q ultimate bearing capacity divided by the factor of safety. So we just calculate the Q ultimate. Now we divide it with the factor of safety given in the question. So we have this value for the Q allowable. 359.43 kilonewton per meter square. Okay, now we will proceed to the next question, which is we need to determine the Q net allowable. Okay, the B. All right, so the next step is to calculate the Q net allowable. So how to get the Q net allowable? The Q net allowable can be determined from this equation, which is Q ultimate minus with the Q divided by the factor of safety. Okay, knowing that this is the overburden in this at this area. Okay, so what we have here is Q equivalent to unit weight of soil here times with the depth of foundation. So we just substitute all the data. All right, so we have the Q ultimate calculated in previous steps, and then we have the unit weight gamma here and the depth of foundation, and don't forget to divide by the factor of safety. So now we have the Q subscript net allowable. Now we go to the C. We need to determine the allowable load, capital letter Q subscript all. All right, so to get the Q capital is actually based on the area of footing. So from the Q allowables, we just times with the area of footing, given that this is the size of the foundation. Okay, so we know that the area of footing is 2 times 2. So we already have the Q allowable that we calculate in question A. All right, so we just need to times with the area of footing. So you will have the Q capital letter subscript allowable in the unit of kilonewton. And then finally, we need to determine the net allowable load. Okay, Q subscript net allowable. All right, so the concept is similar with the step number 7 here. All right, so we need to times with the area of footing, but we need to use the Q subscript net allowable here as we calculate it in step number 6 here. All right, okay, so we already have the value 351.18 kilonewton per meter square. So we just time with the area of footing, which is 2 times 2, right? And you will have the value of Q allowable net is 1404.72 kilonewton. All right, so for the Q allowable, okay, for the Q allowables means that the bearing capacity of the soil received from the overburden surcharge here, and also from the structure, the overall elements. But then for the Q net allowable here, just consider about the structures only. That's all for the example 1. Thank you.